Hey everyone, my name is Nic Raboy. So I work for a company called Couchbase. It's going to be included in this presentation. It's not the whole aspect of this presentation. I'm by no means trying to sell you anything. It's an open source product. I'm a developer advocate for Couchbase. So my role is to educate people like you on how to use cool technologies with Couchbase. I actually work from home in Northern California, and then I just travel a lot on top of that. Tonight we're going to be focusing on developing serverless applications using Node.js and Couchbase. Has anyone had any experience with serverless before, or functions as a service? So this would be a relatively new topic for most people in here then. Is everyone here part of the Learning Fuse? Anyone not part of Learning Fuse? Let's go there. All right, so a few people. Great. So I'm trying to make it easy so that way everyone can follow along, and then hopefully by the end of this you'll have some experience towards building an API with something other than, say, Express Framework for Node. And feel free to ask me any questions as we go along. We'll save them to the end. It's totally fine. Doesn't matter. So first of all, let's take a step back and look at traditional API development without serverless, even though that I have serverless here. So traditional hosting, typically you're working with virtual private servers. Maybe you're using DigitalOcean, Linode, EC2, things like that. Maybe you're using a virtual machine or Docker, or maybe you're using bare metal servers. This is all traditional hosting. Now, if you were to build a traditional hosted app, it might look like something like this. Has everyone had exposure to this? This is a Express Framework application in its simplest form. You're building one endpoint here. It's the root path, and it returns just this hello world message if you try to consume it. The thing about this is, even as simple as it is, if you were to try to host this on any kind of traditional hosting environment, you're paying for uptime. And uptime for a very simple application like that is probably more expensive than it's worth. So I personally use DigitalOcean for my own applications. The cheapest you can get there is $5 a month. That's overkill for this particularly small application. You're also paying for hardware potentially, and it's not as easily scalable as it could be. So if I wanted to scale that very simple application out, typically I would get more nodes in a going on as far as this application goes. Then I'd install Nginx and use a reverse proxy to load balance these API servers. It's not impossible. It's not even entirely difficult to do, but it's a little bit of a hassle sometimes. Or you have to burden yourself with infrastructure. Serverless is a little different. So serverless is usually provided by a cloud vendor. So AWS, Microsoft, pretty much every major cloud vendor has some kind of serverless implementation right now. They're all a little different. Tonight we're going to be focusing on AWS. Or you can go the open source route and use Apache OpenWhisk if you wanted to, and set it up yourself. Serverless does not imply that there are no servers involved. It's just this random term. I don't know how it came to be. But there are still servers involved in serverless. It's just a concept of how you're working with your servers. So how you're working with it is, with serverless, you're billed for the number of requests that hit your function. So you're doing functions as a service. You're also billed for how long those functions take to execute. So if you have a very simple application like that hello world, it's probably going to execute very fast. So you don't have to worry about the duration. You just have to worry about the number of requests. It's ideal if you're writing efficient code. If you're writing an application that's taking 10 or so minutes to execute one of these functions, you're probably going to burn through a lot of money, probably more money than you would in a traditional hosted environment. So you might use a VPS in that condition. These are meant to be very fast. There's no infrastructure management. This is all in the cloud. What you're doing is you're writing functions and you're uploading it to whatever cloud vendor that you want to use. And the cloud vendor takes care of everything else. It takes care of the scaling. It takes care of all of the machine infrastructure. There's no application bootstrapping. You're literally writing a function and you're deploying it. So there's no Express Framework or anything like that. One cool aspect of serverless is there's this really neat framework called Serverless Framework. It's not built by Amazon. It's not built by Microsoft. It's an open source project that makes it very easy to write these serverless applications. So one advantage of Serverless Framework, and we're going to be using this tonight. I'm going to be coding along, try to make it easy. One main advantage of Serverless Framework is it allows you to test and develop everything locally. You don't have to write your functions, upload them, and then test them in the cloud. You can do it all locally, which makes it very convenient and easy to do. The supported platforms for Serverless Framework, pretty much all of them. If you go to their website, it's everything that I've ever heard of, and then plus more that I haven't even heard of. So if you wanted to use Serverless Framework, you could use this framework, develop once, and deploy to any one of these major cloud vendors pretty much without changing any code. So if you decide one day you want to do Amazon and then you want to switch it to Microsoft, you can do that easily. I don't think, maybe 99% of your code is very reusable in these cases. As far as a serverless framework application goes, when you create a new project, you'll end up with a YAML file, which is a configuration file. You'll define all of your plugins in that file. You'll define all of the available functions that you'll be using, any kind of endpoint configurations for your API. You'll have JavaScript files, which will actually contain your functions. And then you'll have NPM modules, so node modules. Just because when you're writing serverless applications, they don't need to be APIs. They could be actual just functions that you initialize through some kind of cron script or by some other means. It doesn't need to be an API, even though that tonight we're going to be building an API. Like I said, we're going to be focusing on AWS Lambda and AWS API Gateway. But then again, we're using Serverless Framework, so it doesn't really matter in the end. Now, in terms of what these functions look like, this is an example of what you would get when you create a new serverless framework application using the generator. You'd get a simple hello world function, and it expects that you return a response. As far as the parameters for this function, you have an event, which you can collect any kind of event body from your request or any kind of event parameters. You have a context, which you can gather information about the function itself, so maybe how long it's been running, things like that. And then the callback on what to do upon success or error. So in this case, we're doing a success. We're saying it's going to return a 200 response, and we're going to say hello world in a message. We're also going to return whatever is available as far as the event, so whatever was passed into this function. And then the callback for the error is going to be null. The YAML configuration file for this is very simple as well, most of which is already bootstrapped by Serverless Framework. You provide information about the cloud vendor that you want to use. The functions, we have one function called hello world. What you wouldn't get by default is you wouldn't get any kind of events. It'd just be a plain old function. Events is where you define if you want it to be an API endpoint. So if you want it to use an API gateway of some sort. So in this case, our event would be a GET request, and it would be at the path hello world. So whatever we're serving on /hello world, and that would call that function and give us whatever that response would be. For plugins, this is a plugin if you wanted to test your API offline. By default, you're not going to be able to have API offline testing out of the box, but the plugin is just an NPM module, and then you could hook it up, and then you can test it just like you would any other Node.js application. And then if you're using an API, the function itself hasn't changed. If you're testing it locally, you just do serverless offline. Now the last step before we actually start developing an application is we should probably learn a little bit about the database that we're going to be using. So it's going to store all of our data for this example. We're going to do a full CRUD application, so we're going to be able to create data, retrieve data, update data, and then delete data. So Couchbase, so it's a complete database solution. It's open source. So there's three parts to Couchbase. There's an embeddable database. There's a cloud database, which we're going to be using tonight. And then there's synchronization support between the two. So as far as the embeddable database, this is primarily focused on mobile applications. So if you're building an Android application, iOS application, it's a drop-in replacement to SQLite. So that way you can have a flexible NoSQL database offline on your actual mobile application. In terms of Couchbase Server, it's a distributed NoSQL database. It's a document database, so you're going to be working with JSON data. And some cool features of Couchbase is it has caching built in. So any interaction you do against the database, it's going to be against the cache first before the persistent disk, making it very fast. It's also a peer-to-peer database. So every node is aware of every other node in the cluster. So there's no master-slave relationship, things like that. It makes it very convenient when it comes to managing more than one node. Then finally, the synchronization component. So rule of thumb, you should never have your client-facing application communicate directly with your database. Instead, the synchronization component is a middleware. It's a web application. It handles all of the authorization, authentication, any kind of data partitioning, any kind of conflict resolution in case you have multiple devices trying to edit the same piece of data. It'll manage your conflicts for you. It's just a middleware for your application. Now, does anyone have any hands-on working knowledge of NoSQL? Just a little bit. All right. So how about relational databases like MySQL, Postgres, things like that? All right. So then this slide might make a little sense for some. So on the left, you have a traditional relational database structure. You have tables, you have rows, and you have columns. In this example, let's say that this is some kind of job listing. And if you ever wanted to query it, you would query probably none of these independently. You do some kind of join and join all of this data together. In a NoSQL database, because instead of doing a join, which is kind of complex and resource intense in some cases, it might make sense to store all of that data in a single JSON document. So that way, if you ever need to request that data, you're making one very simple request. It's very fast. So that's one benefit or one way that you could store your NoSQL data. Another way is, well, you could break it up into multiple documents and still kind of keep that same relational database approach. The difference here is that the database isn't going to manage any constraints for you. It'd be up to your application logic to manage the constraints. So it's totally up to you how you decide that you want to model your application. Now that we have kind of an overview on everything that's going on, I do want to boot up my editor. We're going to start walking through building an application. You'll find that hopefully it's very simple to do. And then you can take it on and do it yourself at home as well. Do you have any questions up until now before I open up my editor? All right, perfect. So I do have an instance of Couchbase running already locally on my machine, and I'll zoom in. Is this visible in the back? Perfect, awesome. Yeah, so this is what you would get after you install Couchbase, whether you do it with Docker or whatever way that you wish to install it. You get a web dashboard. I have one node. It has all of the services that I have actively running. What we're actually going to focus on is our buckets. So buckets are, they're sort of like collections of documents. So you'll typically have one bucket per every one application, and you'll have any number of different types of documents in that one bucket. So for example, if I click on this example bucket, you can see I have varying formats of documents. None of them have to be the same, totally up to you, but this could represent an entire application. We're going to be using this example bucket for querying. I already pre-populated it with some dummy data here. Not very relevant at all, but it's just kind of an idea. So if I find my terminal here, I'm going to zoom in. Is that visible in the back? Perfect. So I do already have Serverless Framework installed. Serverless Framework is a npm package, so you could just say npm install serverless and then global, and then boom, you have it ready to go. So what you can do is I'm on my desktop, I can say serverless, and I can say create. I would define the template that I want to use. And if you ever see me type something wrong, let me know. This is a new keyboard. It's one of those new Macs. It's got a funny keyboard, so I'm going to make a lot of typos probably. So if you catch them, please call it out. I'm going to say what template I want to use. In this case, I'm going to say I want to use the AWS template for Node.js. And there's many different templates. I don't even think it's restricted to just Node.js. If you're familiar with other technologies as well, you could probably use it in the language of your choice. And then I'm going to say the path on where I want to create it. So I'm going to say just on my desktop, and I'll say OC project. Just give it a random name there. And it'll go ahead and create it for me. I can navigate into it. And what it does is it gives me two files. It gives me a handler.js file, which is going to contain all of our functions, and it gives me a YAML file, which is going to have all of our configuration. So I'm going to open that up in my editor. And we'll start with the YAML file, and I'll zoom in. Is that visible? I'm going to remove all the comments. I know that they're very unclear because they're very gray. If I remove the comments, is the other font colors fine? the green and the red? Yeah, all right, yeah. So we don't need the comments anyways. I'm just going to strip them out. All right, so we have a very stripped down YAML file now. So most of it was just comments. And now if I wanted to boot up my handler.js file, this is the same code that you saw in the slide, minus that hard to read comment, which is unimportant for this case. But we're going to start building our application that interacts with our database. But before that, let's run that. Let's see it in action so that way we know what we're working with. So I'm going to go back to my terminal here, and I'm going to say serverless invoke local, because I'm running it locally. Had I removed the local and had I deployed it to, say, Amazon, I would just provide it with the Amazon information. And I'm going to say function, and then our function is actually called hello. So as a result, I return that callback information. Now, if I wanted to, right now, it's not set up to be an API. What we can do is we can actually start setting that up. Let me fix the indentation. So YAML is very picky when it comes to indentation. So I'm using 4 spaces. I think it defaults to 2 here, so I just cleaned it up a bit. What I want to do is I want to say events. I'll say HTTP get hello, and we need that plugin so that way we can test it offline. So I'll install it with npm. So serverless offline, and I'm saving it as a developer dependency. What I can do now is I can include it as part of my plugins. And save it, and let's try to run it. So I would say serverless offline, and it detected that I have one route set up for HTTP events. So if I went to my browser and I tried to say localhost 3000/hello, it returned that message as well as the event data that I potentially passed in. So it has a bunch of other stuff. But if I passed in some kind of body or any kind of parameters, it also would have presented that as well. But I didn't. So this is just meta information about whatever serverless is collecting for us. Not important for this example. So next thing that we want to do is we want to start designing our functions, actual functions, something usable. So we will need to install an SDK for Couchbase, just like you would any other database. We can go back into our terminal here, and we can say npm install Couchbase. We're also going to install UUID. So with a NoSQL database, often you'll find yourself having to define your own keys. You can define these keys as any piece of data that you want. It could be Nic Raboy if you wanted it to be. In this case, I'm just going to keep it unique with UUIDs. And I'm going to say save. All right, so we're good to go now. So what I want to do is I want to go into the handler file, and I want to connect to my database now. So we're going to say, well, first of all, I need to import those 2 libraries. So I'm going to say constant. I'm going to say Couchbase equals require, and UUID. Now that they're included, what I can do is I can say, well, first of all, we need to establish a connection to our cluster, which in this case is 1 node on my machine. I'm going to say cluster equals new couchbase.cluster. I'm going to provide it the host, which is localhost. If I wanted to, I could provide multiple hosts in that string. It's a peer-to-peer database, so you only need to successfully connect to one of those nodes, one of those hosts, and then it'll be aware of every other node. But maybe, for example, that first node is down, it'll try the next node, and then it'll have all that information that it needs. Once we try to establish a connection, we need to authenticate. Inside of Couchbase, I actually do have a user account created. So security, I have an account called example. So we're actually going to use that. It's already pre-created that I created. So I'm going to say cluster.authenticate example. I'm going to use my very strong password there. And I'm going to try to connect to that to that bucket that I demonstrated called example. It's just a coincidence that my bucket has the same name as my username. Doesn't need to be that way. So I'm going to say bucket equals cluster.openBucket. And in those 3 lines, that's how you establish a connection to your database, at least for Couchbase. So we have a connection established. Now we need to create our first function. We already have data in the database, so it might make sense to do kind of a retrieve function before we do a create. So what I can do is I can say module.exports. Let's give it a name. It doesn't really matter the name. Call it create. Well, this one's a retrieve. Say event, context, callback. So the first step for the retrieve is, so another cool thing about Couchbase is you can actually run SQL queries in it. So we're actually going to do our querying for data using SQL. So what I'm going to do is I'm going to say statement, and I'm going to give it a simple select query. I'm just going to select all properties in my NoSQL documents from the example bucket. And I'm going to say where type. So type is a property. I'll go back to my database here. I'll click on documents. So for example, I have a property called type in my document. So I'm going to say where type equals person. So it'll find all documents that match that criteria. So that's a string right now. We've got to convert it into a Couchbase query. So we can say var query equals Couchbase. So Couchbase's implementation of SQL is called Nickel, N1QL. And we're going to say from string statement. And then we can execute it. So we can say bucket.query. We're going to pass in the query, and we get a callback as a result. So we're going to say error, catch the error, or return the result. And this is where we handle the actual serverless framework callback. So if there was an error, if there was an error, let's catch it. I'm going to copy and paste some code here. Actually, let's just say return callback. For the actual error, I'm going to say, what is it, status code. We'll say 500. I'm not a pro at status code, so that may not be the best one to use. But we'll just say it's a 500 error. For the body, what we're going to do is we're going to serialize an object here. So we're going to say json.stringify. We're going to say code. It's going to be error.code. And message is error.message. So that's in the event that it fails for some reason. Maybe it's a malformed query. Maybe there's some kind of connection issue with the database. Fails for any reason, it's going to throw this error back. Otherwise, what we're going to do is we're going to say callback. And I actually forgot the second parameter here. It may not actually be required, but null. The first parameter here is going to be null. No error, we're succeeding. So we're going to do the same thing again. Status code. This time it's going to be a 200 response. And the body is going to be json.stringify and then result. So what was responded with as far as the query goes. So I saved it. We can't just run it yet because we haven't hooked it up in our configuration yet. So we have to go to the serverless YAML file, and we need to add a function. The name doesn't really matter. It doesn't have to match, but we'll make it match. Retrieve. The handler, this does have to match. So handler is handler, so that's the name of the file. So handler, and then we also called it retrieve. And then events. This is also going to be a GET request. We're trying to retrieve data. So it's going to be get, and we'll call it retrieve. Unfortunately, well, it's not running, but if it was running, serverless offline doesn't hot reload, so you would need to stop it and start it again. So we'll say serverless offline. It's running. It's detected now that we have two different routes. And if I go to my web browser and I choose my endpoint, I can say retrieve. And it found one record. There was a bunch of documents in that one bucket. It found one record that matched the person type criteria. Now the next step is, well, maybe we want to create data because we're doing the full CRUD application here. Oops. So let's define another handler function. And you can create as many of these functions as you want. They all scale independently when it comes to serverless. What I'll do is I'll copy this to save me some typing. This time around, maybe we can call it create. We won't be using a nickel query for this case. We could if we wanted to. I think it's a lot easier just to use the API that ships with Couchbase when it comes to inserting documents, but it's more or less your preference. What we can do is, so I'll strip this out. Since this is a create, we could probably make use of that UUID package I downloaded. So I'll say ID equals UUID.v4. That'll give me a unique ID. The next step is, well, we're going to have a payload with our request. So we need to extract it from the event. This payload is going to contain all the data that we want to save. So I can say data equals, it actually comes as a string, so we need to deserialize it back into an object. So I'm going to say parse instead of stringify. And I'm going to say event.body. So this is the post body that we're going to have. I'm not going to do any kind of data validation. You definitely want to do validation in a real scenario. Don't ever trust what your user provides you if it's going into a database. Now that we have the data, what I can do is we can say bucket.insert instead of query. We pass in the ID. We pass in data. And it's still going to have a callback with an error and a result. If there's an error, we're going to do the same thing that we did previously. If it was successful, what we can do is we can return whatever we want. In this case, let's just return the ID that was inserted. So I'll say ID. I'll save it. So we didn't really change a whole lot. Most of it was in the top 3 lines here, just collecting the data, doing a bucket insert. We go back to the serverless YAML. I'm going to clone this line. Instead of retrieve, we'll call it create. For the events, though, this time, since we're actually going to create data, we need to do a post request instead of a get. And we'll call it create this time. Now I'll restart serverless. It's listening. It found my next endpoint here. I'm not a wizard when it comes to curl, so I'm actually going to use Postman. Has anyone used Postman before? Yeah, it's probably the market standard, right, when it comes to testing APIs. I'll zoom in a little. I don't have zoom configured. I apologize if it's a little small in the back. I don't have zoom set up right now, but I'll read out whatever I'm doing. So what we're going to do is we're going to do a post endpoint. The path is going to be localhost port 3000/create. We're going to be sending over a post body. It's going to be in JSON format. We can say first name. We can say last name. We can give it a type. You should probably hard code this in your application, the type, but I forgot to do that inside of the handler function, which doesn't matter. Doesn't matter what we're providing for this example, but for the type, we're going to call it person. And I'm going to send it. And as a result, I got an ID back. So if I wanted to, I can go back to my Couchbase dashboard to validate that data was actually inserted here. It did show up. That ID up here, this is the ID. It should match what was returned. So everything looks all right for now. I can go back to my retrieve endpoint and refresh. The result showed up because it matches my query criteria. So all good so far. Now we got to worry about updating. So these are functions. So when we're working with functions, we don't have all the luxuries that we might have with the traditional REST API because, like I said, the longer your function runs, the more you're going to get billed. So in the scenario where you're working with documents that are, say, 25 megabytes in size, those are going to be slow to pass around the network from database to function and so on and so forth. So if we wanted to do an update, we don't want to have to first download that entire document, make the change, and then upload it again. That'll be very expensive. So what we want to do is we want to edit parts of the document directly on the database server. So that's fair game here, and that's what we're going to do. Oops. So I'll go back here. We're going to create another function. What I'm going to do is I'm going to copy this again to save me a little typing because it's more or less the same thing. There's going to be a trend here. So I have create. Let's call it update this time. We're not going to generate an ID in this circumstance. We will be getting data from the request body. But what we want to do is we want to actually create a mutation builder. So we're going to actually mutate these documents. And this mutation builder is going to work off of the input data. And I'm not validating any of it. Whatever somebody provides, we're just going to save or update or replace whatever they provide. So what I can say is I can say var builder equals, and I can say bucket.mutate in, and I provided an ID. So this ID can come in the payload, or if we really wanted to, we could obtain this ID through the route parameters or the path parameters. So before I continue filling this in, if we head over to the serverless YAML file, we can define those path parameters. So I'll create another function definition. It'll be update. It'll be an update function. Since we're changing data, instead of a post request, it should be a put request. We'll call it update, but we're also going to provide a variable. So that's a path parameter. We're going to be passing in an ID through the URL. And we can actually obtain that by saying event.pathParameters.id. So the ID is what we named it. So we have the builder started. What we can do, since we're not doing any kind of validation here, we can say for, we can create a loop, we can say prop in data. So we're just going to loop through whatever data is, look at all the properties, and we're going to say builder.upsert. So an upsert is a create or a replace. So if the property does not already exist in our document, it's going to create it. If the property does exist, it's going to swap it out with whatever we're providing. And there's other things that you can do. You can just do an insert if you wanted. You could do a straight replace if you wanted. Totally up to you. But we're going to say upsert. The property is going to be what we're after. So that's the path. It could be more complex than a root level path. So maybe you have some complex JSON data going on in your documents. You can update any part of that path. And I'm going to say data prop and end it just like that. So we have the builder, and we need to execute it. So instead of insert, we're going to say execute, and instead of bucket, we're going to say builder. We're going to pass in. Oh, actually, we're not passing in anything. What it's going to do is it's only going to return an error. It's not going to return a result this time. So if there's an error, we're going to catch it. If there is no error, let's just worry about passing back the ID. Again, you can pass back whatever you want, whatever makes sense to you. We're going to say event path parameters .id. I can save it, and we can go ahead and try it out now after I restart it. So it's listening. It found my put request there. I'm going to go back into Postman, and I'm going to say put. I'm going to say update. I have the path here, so I'm going to include that ID from what was returned. That's what we want to update. As far as what we want to update, let's just update the first and last name. Let's go ahead and change it up here, and maybe let's add another property. What should we call it? Anything? Favorite. We'll just call it that, and we'll send it. So it returned the ID because that's what we expected. If I go back to the database now, or in fact, I could just run it from here. It added that property because it's doing an upsert, it's doing an insert or replace, and it actually updated the data as well. It didn't insert a new record for us this time. So that's a cool thing about mutations. We have one endpoint left. It's going to be the same trend that we've been going on this whole time. So if I go back here, let's go ahead and copy this insert code. And I'm going to call this one delete. This time around, and there's a debate whether or not you should include the ID in the path parameters or the body. I guess it's more of a preference than anything. I'm going to include the ID this time in the body. So it's not going to be in the path parameters. So we're going to parse that body out. And if there's, we're going to say remove. And we're going to say event.body. It's not event. It's data.id. And again, I'm not doing any kind of validation here. I should definitely do some validation here in real life. But I'm saying data.id because that's the property that I want to obtain. We're not passing any data in. It's going to be a straight remove. If it succeeds, we're just going to return the ID back again. Doesn't really matter here. So that way maybe we can say, you know what, that ID was just deleted. And our front-end logic can do something with it. So I'll save it. Go back to serverless YAML. Do a copy-paste again. This time around, we'll give it a name. We'll call it delete. This is the delete function. Instead of post or put or get, we're going to say delete. And save it. We can restart our application now. Go back to Postman. I'll provide this ID again. Oh, it's actually already up there. This time it's going to be a delete. Change this to the delete path. And you know what? We're actually not using the path parameters this time. It's going to be in the actual body itself. So ID, passing in the ID. I'm going to hit send. It returned. What we can do is open up the web browser, refresh, and it's gone. So this is a full CRUD application. So this is using serverless. So if I wanted to, I could take Serverless Framework after I open up my Amazon account or whatever account I wanted to use. It would ask me for my credentials. I would say serverless deploy, and it would deploy it to wherever I've defined my credentials. So it'll deploy it, and it'll respond back with the access link on how to access it remotely. It's very simple. There are some catches, though. So if I open up my slides again, so there's a catch. You're working with native dependencies sometimes when it comes to Node. When it comes to NPM, sometimes you're working with dependencies that are designed strictly with JavaScript. Other times you're working with dependencies that have some kind of C or C++ compiled components to it. So for example, in the example of Couchbase, there is a compiled component to it. So Lambda, in this case, is not Mac or Windows. It's a flavor of Linux. It runs its own architecture. So if I were to do an npm install on my Mac, essentially when I say deploy, it's going to zip up my node modules directory and push it up to Amazon. And Amazon isn't going to know what to do with those node modules because they're set up for my Mac. So what you have to do is you have to kind of do something outside the box here. And the easiest way to do it is with Docker. So Amazon did release an official image for Docker called Amazon Linux that's designed after their Lambda. What you can do is you can actually deploy a Docker container, have it map a volume. So your project directory on the host machine would be the volume. And then using IT Interactive Terminal, you could connect to that container, say npm install from within the container's terminal, and it would do an npm install, and it would gather those dependencies on your host machine because it's mapped. And then when you say serverless deploy from your host machine's terminal, it'll bundle those Linux version of those dependencies and deploy them to the Amazon cloud, and at which point they'd be usable. It took me quite some time to figure this out because the logs that Lambda was spitting out when it came to native dependencies were not helpful. They they sent me around in circles on this one. So this could save you a lot of time when it comes to deploying your Node application. And the same rules apply to all of these cloud vendors. It's not just Amazon. When you deploy an application, it doesn't do an npm install on their server. You're bundling your code and all of its dependencies and pushing it up. So what's next as far as getting help and learning more about this? So for one, Serverless Framework, again, it's an open source framework. Definitely worth checking out. It has pretty good documentation to get started. There's not really anything more to it than what I already showed you in the slides. You just have to come up with your own imagination on what you want to deploy as a serverless technology. You can reach out to me on Twitter. I'm Nic Raboy. It's not NRA boy. No gun affiliation. It's just my first initial last name. I know it confuses a lot of people. Or you can go to either one of these blogs and get whatever information that you want as well. I'm open to questions if you have any questions.
Yes.
What are some applications for serverless?
Yeah, so there's some examples. So you definitely want to create serverless applications. Like if you know that you're going to have infrequent requests. So maybe you have a report that you need to run, and that report is run once a day. Doesn't make sense to host that full time. That's a good use case of a serverless function. Maybe you have an application that has crazy kind of requests throughout the day. It's totally random. Some points of the day you get outrageous numbers of requests. Some points of the day you're receiving hardly any. Maybe it doesn't make sense to have a VPS, because if you're getting crazy amounts of requests, you're probably going to need a very expensive VPS. So having the ability to have it automatically scale on demand is a good use case of serverless.
What's a VPS?
Virtual private server. I mean, yeah, I think that's the norm, right? VPS is what a lot of people are using, or company infrastructure. It depends on where you work for. Yes.
Like serverless seems like very attractive. You only pay for the function that you use and everything. Why would you not use serverless? Like, what are the instances like?
So, I mean, it depends. Off the top of my head, I'm drawing a blank. Anyone care to comment on what their interpretation of that would be?
You said for reports that take a really long time to run.
There you go. Yeah, so if you have something that, maybe you have some media processing. And,
like pictures and
sure.
everything?
Yes.
Can you build a full-fledged web app?
Yeah.
So where would the HTML CSS go?
Oh, in that case, no. So this would be your back-end API. So this you wouldn't be hosting any kind of front-end application as serverless. You would still need traditional hosting for that, or S3, or whatever is compatible for serving up HTML. Yes.
What are like are there like plugins and stuff like that that are required for the front end to actually communicate with that?
No, I mean it's API. So if you're using Angular or React or Vue, they all just need to issue HTTP requests to this API. You need to make sure that your two servers are able to communicate. So you need to be able to make sure your firewall rules are in place correctly, which is something that throws me off all the time. Or if you're not using an API at all for serverless, maybe a cron. Maybe you have some kind of cron that does an invoke of your function rather than an HTTP request. Well, thanks for coming out, everyone.
Hey, I'm VJ. Thanks for coming to the meetup today. I'm the organizer for JavaScriptLA. I wanted to just personally thank you for watching this video. If you found it useful, I'd love for you to subscribe to our channel. We're slowly but surely making lots of little video content for you guys to enjoy and soak up, especially if you want to get better at programming. I'd love for you to be on our Slack channel too. Over 800 users. The link is right here, jsjoin, jsjo.in. If you forget, it's really simple. If you have questions for this meetup, or questions you didn't get to ask, or because you couldn't make it, we'd love to have you just post it in our Slack group. So if you're a newbie, don't worry. It's a good place to go. There's a lot of great engineers all connected around LA and Orange County, so I hope to see you there.